So I've decided to show everyone some of the things that are happening in Agent 1218 pathogen, and today we're going to start with this VR drivable vehicle. I'll just show you what it looks like. Where are my controllers? Here they are. That car's gone fucked. I had a fear I was bugged. Okay, so you can see we have a drivable car, so let's just have a look at its code, its blueprint. If it'll let me. What's going on? There we go. Let's start off with the components list. We have our mesh here, which is just our rig. We have a steering wheel cube here, which is for the steering. You have a scene here for the door route, which the door is attached to. You need that to actually move the door. And then we have the door for the right hand side. Door box, which is down here. This is for the sound effects. We have the inner door box to grab inside the car. We also have an arrow here to keep our hand attached. That's where we want our hand to always be at that location. We have the door outer box, which is what we use to grab the handle, to overlap and say we're near the handle. We have another arrow for our hand location. We have our possessed box and our unpossessed position. We have our steering wheel in here. We have our right hand position, our horn box, our steering wheel spline, which we don't need. I just added that because I wanted to try something else with the steering wheel. We have a steering wheel volume. Where is it? Is that hidden? So I've created myself a donut, and I've used that for the overlap for the hands. If the hands overlap this, it'll say it's near the steering wheel. We have our left hand pose for the steering wheel. We have our passenger position, which is just an arrow. This is where a passenger can get into the car. We have our passenger seat position. We have our mini map just over here, which is a widget, so you can't view it at the moment. We have our gear shifter for changing gears. We also have the shifter itself. We start off with the scene and then have our shifter. And now we have our hand position for our shifter. and our volume box. Next we have a land arrow, which is down here. Can't really remember what that does, but you probably don't need to use it. We've got our engine sound. We've got our left door. We've got our point light. We wanted a light inside here so we could see everything. We have our door closed box, which is also for sound effects. So when this overlaps that box, it makes a sound effect, and when it unoverlaps, it makes another sound effect. We've got our headlights, which is a separate skeletal mesh. We have our point lights. We have our body mesh. I just want to check the collision on this. Yeah, it's been bug jar. It's supposed to be vehicle. We also have our engine down here, which I'll try and show off. It's turbocharged, so yeah, sick. We have our start button to start the vehicle. We have our start button box. We have our drive, neutral and reverse mesh. We have a bonnet arrow. Just here, that's where our bonnet attaches to. So we can grab the bonnet, lift it up and show the engine. We have our bonnet box, a bonnet arrow. We also have a miles needle, which is just in here. And we have our RPM needle, which is just there. We've got our VR origin, which is just a scene. We've got our VR camera, we've got our right motion controller, we've got our right hand mesh, we've got our right fingers, we've got a right finger capsule, which doesn't have collision at the moment, but you can turn on collision, and that's where you can actually start the car with your finger. We have a hand sphere, so that our hands can overlap boxes and everything. Got our left motion controller, our left hand mesh, our left fingers, our left finger capsule, and our left hand sphere. And we have a vehicle components. So let's go into our event graph and have a look at all the code that we have, starting from the top. We've got our finger scales, which this helps you grip the vehicle. As you can see, we are doing invalid. And then we check a few things, and put some branches and a clamp with 0.9 here, 0.9 there, and 0.9 all over here, an AND branch, more branches, and then we play a haptic feed. This allows us to have haptics when we make a fist and make a resting hand pose. And we do this for the fingers, we do this for the grip. Next we've got our event graph tick and our post we can play. I'll show you those later. We also have an input graph, but I'll just show you the overlaps first. So we have our overlap pose box, we're getting our character, and then we're saying near agent car, we're setting a boolean for that, and we're saying near bike, which we can get rid of that. And this is where we unoverlap and we say we're not near the agent car. And on unpossess, we have our door R open, so is our right door open? We say yes, and so we stop the motor event. This stops the start button dynamics and stops the engine sound. The vehicle puts on the handbrake, turns off the engine, boolean, and sets that to a do once. What else do we have down here? We've got get all actors, so we're getting all actors. We're getting the actor for our VR chart, we're getting the 0 index, and we're going to go detach from actor, set actor enable collision, set actor hidden in game. We've also got this in between here, which is set car attached. We set actor location unposed box. This makes our character set its location to what I believe. Where are you? Okay, we're just getting off the get to this unposed position. Then we set actor rotation. This sets our rotation. We get our rotation, then we get the unposed rotation with the z-axis, and the roll and the pitch goes into that one. Then we have an boolean which we named engine on, and we turn that off. We set the handbrake on, set driving vehicle boolean off. We set the visibility for our right fingers, right hand, left hand mesh and left fingers. Then we get our game state and change. You don't have to actually do this part, but we're changing the player actor, which is in our game state, and we're possessing the character, our VR character. We're getting the left right motion controller, and then we're setting the world location and rotation of our VR character's right hand to set relative transform. This transforms the hand back into its positions and the left hand back into its position. Okay, let's have a look at event unpose. First we stop the engine, then we set the handbrake on, then we turn the engine off, boolean off. We get our minimap, which you don't have to do, so don't worry about that part. You just want to get and go detach, and then check if it's valid. And you also want to check if the character is valid. Then we set actor transform to our minimap arrow. You don't have to do this part, I don't think. Attach actor to actor. And what is the target for this? Our target is our minimap actor, and our parent is our character. That resets the minimap to our character. And then we get all the minimap, and then we attempt to initialize. You don't have to do any of this whole part here. We don't need this anymore. And go to this overlap. So we have our door handle out box, which is our outer box. We get a tag component name. So in our VR character, our hands, our collision spheres for our hands have a tag called right hand and left hand, and we're checking if they are either true or false. And we get an is valid of our VR character, and then we say R near door handle, and we click that true, or L near door handle, so left hand and right hand. We set our agent car reference to ourselves, and we say side 1, and for our end overlap we get our same thing. We get our tag of right hand or left hand, we check is valid. We turn off our booleans for the right hand near door handle and the door handle grabbed. We also have a let go outside handle. Let's have a look at that. There's just door handle grabbed, boolean is turned off. This goes into a branch. We also have an input of right hand in there. We get our character, we check is valid, we then get our motion controller, and then we set the world location and rotation. And that'll be for the right hand mesh. And then we set the right hand mesh back to its position, set collision enabled, our physics constraint our right hand position box and our right hand mesh, set constraint components, and then we simulate physics. And then we go into here, we get our door right hand root, which was our scene that our door is connected to. We get the z-axis for that, we minus that by the z-axis of what was this for? When did I do that? Well, I can't really remember what this one's for. But what is this one for again? Previous door rotation. This is our previous door rotation, so we have a boolean called previous door rotation. We have a variable for that. We just minus that, and then we get the world delta seconds. Divided that, and then we go initial yaw velocity. And let's have a look at that. We start simulating door physics. This gives us sort of faked physics for the door, so you can push it and let go and it'll keep moving. We have a door initialize yaw velocity. We have our door right hand root, and we get in the z-axis and we go physics initial yaw angle. And then we get our door time since let go. These are all floats. And then we go into a gate, and down here we have a stop simulating door physics. This goes into the closed. Enter goes into our event tick. Open goes into that of custom event. Then we have our door time since let go. We get our door time since let go plus that by delta seconds, and that's when we set the door time since let go. Then we go into a branch, and we have a whole another graph in here. So we have our door initial yaw velocity minus our door friction times 980 times door time since let go times door initial yaw velocity, and we get a sine float, and that then goes into a minus, and we have a is a less than or equal to 0 or greater than 0, and put that into a select. We also have our door initial yaw velocity is less than equal, that goes into our index, into an OR, and then down here we have our door root. We have our relative rotation. We're using the nearly equal, which is minus 75, and 0.000001, and a nearly and another nearly equal at 0. That goes into an OR, and that's that done. That's our simulating physics, or a part of it anyway. So in this boolean, if it's false, it will be our left hand that gets reset and goes straight into start simulating, so we can open the door with both hands. We don't need to do the start GPS and destroy all lines, you can not worry about that. Door handle inner box, this is the box that you use to open the door from the inside of the car. We have our right hand sphere, which is our hand collision. If that equals, if the other component equals that, and that's true, that means our hand is near the inner door handle and it's our right hand. We can only open the door from the inside with our right hand. Door handle inner box, this is our end overlap, so this is where we turn it off. We also turn off the STR wheel, the left hand STR wheel, the right hand grabbed STR2 wheel, and the left hand grabbed STR wheel. Then we go let go of inner door handle and let go of inner door handle for the left and the right. We door close box, this is where we have our sound effects, so we have our other component equals door box, and print string door closed or door open down here. We're going can close door sound E, can door, and then we set the bottom one with can close door sound E. We have that on. We do a do once. We play the sound at the location. So this is door closing sound, and this is our nution. And then we put a boolean false can close door sound effect. And that would be us. Now we have our steering wheel volume begin overlap. First we get our right hand sphere, then our left hand sphere, and we branch to see if they're true. Then we have our right hand near SDR wheel, which we set to true, and then our left hand near steering wheel set to true, and then we print strings. And now for our end overlap for our steering wheel, we get our right hand spheres and our left hand spheres. We set our booleans to false, and then we print strings. And for the gear shift we do the same thing, but with the hand near gear shifter, hand near gear shifter. And we just have our end overlap for that one. Let's have a look down here. We have our horn box, so it can play horn. Get our right hand and our left hand spheres, play the sound, can play horn turned off, delay, and then can play horn. So you don't play it multiple times within a very small amount of time. You can only honk your horn every 1 second. So we have our grab inner door handle. This is our custom event. This is what happens when we grip the door handle with our character. We play this event, and we're going to branch, say right hand true. Our hand near inner door handle is branched to true. Door handle in arrow for our right hand mesh. This sets our right hand mesh towards the door handle. Then we have our right hand motion controller. Our get world location goes into an inverse transform with our get actor transform, which is our vehicles transform. We get our door scene for our right door. We get its relative location. We get minus, and we put the X on the X and the Y on the Y on an A tan 2 degrees. And then we get our relative rotation and our previous door rotation. We get the Z axis, we put that into a minus here, and we get our Z axis from that one, we put a minus into there. And then we set our door initial grab offset, our inner door grabbed, and it goes into a branch. Then we equal to 1. Then we play sound. This is our door opening sound. And then we get that door scene again. Then we get our relative rotation. We equal that to 0.1. Branch that, and car door opening sound effect goes into that one. So it'll play a sound effect when it equals 1.0 and 0.1. We also have our let go of door. This is our let go of inner door handle. We branch our right hand. We set our right hand boolean to true. We hand near inner door handle. From the branch comes out a true. We get our right motion controller. We check if valid. We then set our world location and rotation to our right hand controller. And then we set our right hand mesh, set relative transform to -8, 6, 90 and 1 all for the scale. We set our inner door grab boolean to false, our right hand to false, get a root scene. We get the yaw from our relative rotation. We minus that by the previous door rotation. Z axis, we minus that, and then it looks like a divide, but I think it's a plus. No, it's a divide. Get world delta seconds divided by that and start simulate door physics again. We've got our left door closed. This is animated to open and close and play sounds. And we have our event possessed. We get our mini map. We set the visibility. We detach from actor. And the actor we're detaching from doesn't matter. We want to keep relative. Then we set actor transform. So we set our minimap actor transform to our minimap that we have in our components. I believe we have a minimap somewhere in here. Yes, we do. We have a widget for our minimap. Then we attach actor to actor self. The target will be the minimap. The parent will be self. Then we get all actors minimap. Get the 0 reference of that. Check is valid, and then attempt to initialize. You don't have to do really any of this minimap stuff on event possessed. We have our grab shifter event. So we got our hand shifter position, and we set our left hand mesh to that position. Set world location and rotation, and this is where we actually move the gear shifter. We get our actor transform, we inverse transform that, we get our left hand motion controller world location, get our relative location for our gear shifter scene, and minus that we put the X in the Y and the Y in the X in the ATAN 2. Then we times that by -1, then we clamp the angle -45 to 45, and then we set the relative rotation of the gear shifting scene Y pitch, and this is where we check whether or not it's greater than 4 or less than or equal to 5 or less than -4 and greater than -5. And then we go to nearly relative rotation to nearly equal 5, error tolerance -5, plug that into a true as well. Then we get a greater than or equal to 40, that branches into a branch there. We have R off, which is a custom function, and we have -40 less than or equal to. There we have our branch coming into that one, and we have door off there, and we'll have a look what door off does. That just sets a material instance. This sets our gear, and this set use automatic gears. Go back onto this and we'll look at R on. We have our material instances that we scalar parameter. So the emissive scale value of 25, and then we set our target gear, which sets our gear, and then we set use automatic gears for that one. And that's about it for these graph. Now we'll have a quick look at our event tick. So the first one we have in vertic is set in air angular dampening. This is just getting our chaos vehicle movement component is moving on ground. Then we put into a select, we put 3 on the B, and then the mesh goes into set angular dampening. Then we have our throttle / steering movement graph, and this is what we use to set the hands to the steering wheel and actually move the steering wheel. So we set the world location and rotation of our right hand mesh to our right hand position, and for our movement we go into get our steering wheel, get the relative rotation, set the relative rotation, and our handle bar rotation mass. So we'll look at that. steering wheel cube. This is where we use the steering wheel cube, and we get our relative rotation from that. Yeah, steering wheel, get world location, find lookout rotation. To our right, motion controller, get world location. This is to steer with one hand instead of two hands. We get our steering wheel, get world rotation, and a get right vector. We get a get rotation x vector, and we plug that into a dot value, and then we normalize the axis. Then we times it by 10, and then we plus it by the roll of the relative rotation of the steering wheel cube, and then we get the relative rotation of our pitch and yaw going into this make rotator. We get our current steering rotation, and then we divide it by 2, and we clamp the angle minus 60 to 60, and then we set the current steering rotation with this brake rotator that comes off the make rotator, and that should be our rotation mass and set relative rotation. Yeah, that's making the right hand move the steering wheel. We'll do the same for the left. We just do it for a different hand. Set handler rotation. We just go set wheel cube. This is for both hands. So we get a right motion controller, get world location, find lookout rotation, get world location, our left motion controller, brake rotator to our Y pitch plus 90 degrees into a make rotator, and that's our output. And then we go set steering input, we get our vehicle movement controller, set steering input, we get steering angle minus 30 for the first A range, 30 for the in range B, and out range is minus 1 and 1.0. Okay, what else do we have down here? We have our hand grabbed SDR wheel, which is true, and our left hand SDR wheel grab is true. We set the right hand steering wheel position, which is just the set world location of the right hand mesh, and the right hand position, get world location, get world rotation, and set that. Then we set the L hand position, and we say both hand steering movement, and we'll have a look at the mass there. We get our relative rotation, and we set our pitch and yaw into a set relative rotation, and we'll have a look at both handle bar rotation mass. We get a steering wheel cube, we get its relative rotation, and you put our X roll into a clamp with minus 60 and 60, and then set our steering angle. We get our current steering rotation, and plus the roll with that, then we divide it by 2.5, clamp the angle again, current steering, set that current steering rotation, and that brake make rotator goes into that output, and that sets our relative rotation. And I think that's it for inputs. No event tick. Now we have our begin play event. First thing we're doing, we're getting our vehicle movement component, and we're casting to our chaos wheeled vehicle wheels movement component, and we're setting a reference for that. And then we'll reset orientation and position for our VR, set tracking origin to local, add mapping context, enhanced input local player subsystem for our player controller, reset vehicle event, which resets our position and orientation, and also sets our actor transform, so we get our actor location plus the Z axis by 50, and then make a transformation, get our actor rotation, plug the Z yaw into the rotation Z yaw, and we set actor transform. We also teleport. We get our mesh, and then we set physics, angular velocity in degrees, 0 on all of them. We get our mesh set physical linear velocity, and it's 0 for all of them. We get our body mesh. We create dynamic material instance for the optics, our brake optics instance. We create another dynamic one. We get a headlight optics for our body mesh. We get our speedo light instance. Our miles per hour needle. We set that to an instance, and we also set the RPM needle to an instance. That's it for begin play, I believe. And now we have our inputs. We have our throttle, which we have engine on, branching is true, so we can throttle. We have our chaos vehicle get engine rotation speed greater than or equal to 4000, and then we play the turbo fluttering sound effect from that. We get our brakes, we set the throttle input to 0, this delay, and then set brake input. Then we put our brake into this value. We set our brake lights on, get our vehicle movement component, set our brake lights off, set our brake input off to 0, and then can use throttle. I don't believe I use that anymore, so we don't need that. Actually, we weren't done in inputs. We set our handbrake input on and our brake lights on. We do our reset, which we've looked at already. We toggle our lights, so we say headlights on, play animation, set scalar parameter value, set a light power 1, set visibility, brake emit to 0, emit for our needle to 0, and for our RPM emit to 0, and our headlights off boolean. And this is the one where we turn it all back on. So we put it to 25, 5, 2, and 2, and our headlights on. We don't have a button for our horn anymore. We have a button to reverse, so you can change gears without having to use the shifter. You use reverse gear if it's true. You to set target gear immediate, and set use automatic gears. Use reverse gear boolean turned off. And this is where we turn it on. This is where we have our right grip. This is where we grab the steering wheel or the shifter. We go hand near gear shifter. If that's true, we grab shifter. If it's false, we hand near inner door handle, and we play the grab inner door handle function, and the let go inner door handle function goes into our completed one. And our set right hand to motion, this resets our hand to motion, which is just setting the world location and rotation, and then setting the relative location and rotation. Then we set the visibility on for our right fingers and our right hand mesh. Then we have our right hand steering wheel boolean, and we branch that if that's true. We right hand grab steering wheel, make that true, and then set right hand to motion and right hand steering wheel. That's if they're false. And down here we basically do the same for the left grip. And what we want is to go into our character class, go over to our right hand grab, and we have our grab door handle, door reference, agent car reference, that's the one we want. We'll grab door outside handle, grab half fist, and that's all we do for that one. And I believe we have the when we let go, we check if it's valid and we play the let go side handle and the grab fist boolean to 0. That's for the animation blueprint. We go back to that, and that's just that. That should be all for the VR drivable vehicle.